The second video, we're going to be discussing the elasticity of demand. So in your textbook, it's chapter 5, learning objective 1, D, E, and F. All right, so it's helpful to understand the variety of demand curves as it relates to their elasticities. Let's take graph A here. A is perfectly inelastic, okay? Perfectly inelastic. And this is really a hypothetical situation. This is the extreme that doesn't happen in real life in practice, okay? So in other words, it doesn't matter how much the price is. There will not be a change in the quantity demanded. And that's what I mean, it's hypothetical, it's false, because even life-saving cancer medicine, even if it was going to save your life at $100,000, $200,000, $1 million, $60 million, $80 million, eventually people will demand less of it. So it's just hypothetical. B is much more common. So at this price point, at $4, because elasticities will be different all up and down the curve, but anyways, at this price of $4, if you move it up to $5, right, the demand curve is inelastic. In other words, a 22% increase in the price only leads to 11% decrease in the quantity demanded. All right, so if total revenue equals price times quantity, would you be better off increasing the price? If all you're considering is total revenue in your decision, would it be better off to increase the price? Absolutely it would. Wouldn't it, right? Because the price increase is going to contribute 22% to total revenue, while the decrease in quantity as a result is only going to lead to an 11% decrease in the quantity demanded. So the pros outweigh the cons in that case. So if it's an inelastic demand, raising the price seems to be a good idea as it increases total revenue. And again, we're not counting costs or other factors such as capacity and things like that. Okay, anyways, moving on to C. C is unit elastic, an equal, the increase in price has an equal effect on total revenue, as does quantity demanded. There's a 22% decrease in the quantity demanded due to the price increase. So there it wouldn't matter if you want to increase the price or not, total revenue would be the same. Here we have elastic demand. Now you might want to notice here when we compare these two graphs, this graph here, right, is much more flat. And graphs that are much more flat, right, as you can see, when we have a price increase or a price decrease, we're going to have a greater impact on quantity. And that's why elastic demand curves tend to be flatter, all right? And it's a tendency that way, okay? And inelastic demand curves tend to be more steep. So what would you do here? Would you do it? Would you increase the price for $4 to $5, right? A 22% increase in price leads to a 67% decrease in the quantity demanded. And so no, if you wanted to increase total revenue, you would not want to increase the price if it was elastic. Unless, of course, there was a movie theater and you had limited capacity in your movie theater and there were people waiting out. There's so many people that wanted to watch the movie. There's a large part of your customers couldn't watch the movie, for example, because the demand was just too high and you had limited capacity. All right, so maybe in that case you would increase your price. Yeah, you would have less quantity demanded, but you're having troubles fulfilling that capacity anyways. So in that case, you might want to do it. But if you're just counting total revenue, you would not want to do it. Why not? Because the increase in total revenue due to the price increase is much less than the impact on the decrease in the quantity. All right, and here we go. In this slide, we have perfectly elastic demand, right? At any price above $4, the quantity demanded would be absolutely zero. Of course, this is just a hypothetical situation. All right, guys, so get your pens and papers and your calculator out. Let's do some work. It says determine if the two following products have elastic or inelastic demand. Okay, so we're going to use our formula there. Product A and product B please calculate the elasticities of each product. Pause the video. All right, now that you're back, I'm sure you've got it all worked out. You're a good student. I know you did. Here's the answers for product A. Okay? We have an elasticity of 1.59. 1.59. And of course, we take the absolute value of the elasticity there, 1.59. And so would we say it has an elastic demand or inelastic demand? Well, the number is greater than 1. So if the number is greater than 1, then we can say that it has elastic demand. All right? And what about the other one? Well, here we have elasticity of 0.5, right? We take the absolute value, so therefore it is less than 1. And when the price elasticity of demand is less than 1, we say it is inelastic. So which product, product A or product B, is more sensitive to price changes? The inelastic one, right? An increase in the price is only going to result in a small decrease in the quantity demanded, right? Very small decrease in the quantity demanded. So should you increase the price? Well, yeah, you should, if you want to increase total revenue and not factoring in a whole bunch of other scenarios. For example, the costs associated. Your cost structure of your company, all that kind of thing. You're just counting total revenue. You would want to increase the price of product B. But what about product A? Would you want to increase the price? Absolutely not. A small increase in the price would lead to a large decrease in the quantity demanded. So hey, what do you guys think? Should you decrease the price then of product A? That might be a good idea. Right? If we were trying to maximize total revenue, right? If we had, for example, a small decrease in the price, that would lead to a big increase in the quantity that would be demanded. Now, if we had the additional capacity, the spare capacity at our factory, and if our costs, we're not factoring our costs, of course, but if our only goal then is to increase total revenue, it might be a good idea for us to decrease the price of product A. All right, guys, let's learn how to determine the impact of a price increase on total revenue just by analyzing a graph. All right? So box A here, I'm drawing green. Box A basically shows the effect of the increase in the price on total revenue. And box B shows the effect of the decrease in the quantity that is demanded. So which one is bigger? Which box is bigger? We know that the increase in price is going to contribute to total revenue, but the decrease in quantity is going to lessen total revenue. Which one is bigger? Well, anyways, you guys know how to calculate the size. I don't know if you can eyeball that. Which one do you think is bigger? Well, let's find out for sure. Let's calculate the area of the rectangle, and we do that by multiplying length times width. So let's look at box B. Sorry, let's look at box A. All right. So length times width. Well, what's the width there? Well, it's 1, right? $4 to $5. That's 1 multiplied by, what is this line? How much? Yeah, it's 90. 1 times 90 equals 90. That's the effect of the increase in the price. Let's examine the effect of the decrease in quantity as a result. Okay, what's this line? All right, well, it's 4. We want to multiply that by the decrease of 10 in quantity. All right, so now we got the area. 1 is a lot bigger. I'm actually surprised a little bit, but there you go. All right, So the effect of the price increase is 90. The effect of the decrease in quantity as a result is only 40. What is the net effect then? What do we have to do? Well, we just have to go 90 minus 40. And that's going to equal 50. So that's a positive 50. So what do we see then, right? We see that there will be a positive impact on total revenue if we increase the price on graph A. Well, let's examine the other graph. All right, same thing. The price changed. The price didn't change. 1 times 90, that equals 90. But look at the effect of the decrease in quantity. It's much larger in this one. It has elastic demand, it seems. All right, so let's check it out. All right, so this line is 4, and basically the difference here is going to be 30. 4 times 30, the area of that rectangle B is going to be 120. 120. So the effect of the decrease in Q is larger than the increase in P. 90, right, minus 120, that equals negative 30. You would lose $30 by increasing the price from $4 to $5 in case B. That's because it has elastic demand, right? The quantity demanded is very sensitive to price increases. All right, so let's talk about elasticity and total revenue along a linear demand curve. That's what we're looking at right here, folks, a linear demand curve. It's a straight line, and we've been taking the elasticity of demand and calculating them at certain price points, like from $4 to $5. What's the difference, right? And we haven't sort of gone along the whole demand curve to see the spectrum of price elasticity of demands that you do find all along a demand curve, even a linear demand curve. Now you might think that, I don't know, the elasticity of demand should be the same here as it is here, and as it is here. And it is not. Okay, so price elasticity is not rise over run. It's not the slope of a curve. The slope of a curve is the ratio of changes in two variables. But elasticity is the ratio in the percentage change in two variables. And that makes a huge difference, a huge difference. So, for example, let's look at the price at $1. So at $1, we are demanding 12 units. If we moved up the price to $2, that's only one step. But what percentage change is that? Okay, well, that's like 100% difference, isn't it? And okay, anyways, and then we decrease, we have a smaller percentage change in the quantity that's demanded. Well, let's calculate this using the midpoint method. Okay, the midpoint method has this fancy formula you guys have all been using. All right, and so let's use the midpoint method to calculate the price elasticity of demand. Right, and what is it really? Well, it's the percentage change in the quantity divided by the percentage change in the price. Okay, and it's the percentage change using the average. So it's a little different, and because we're using the midpoint method. But anyways, just beyond that, let's just calculate this. Get out your calculators, calculate it up. You can pause the video if you want. We get 0.18 on the top side, and we get 0.67. So that gives us an elasticity of demand of 0.27. Please tell me, is that elastic or inelastic? That's right, it's less than 1, so it's inelastic. And we knew that. I mean, it says elasticity is smaller than 1. It is inelastic over there. All right, so that's good. Well, let's take it at another point. let's say we were increasing the price was at $5, and we wanted to determine what the impact on total revenue would be, what the price elasticity of demand would be, by increasing it to $6. All right, again, it's just one step, but the percentage change is quite different. So if you want to pause the video, calculate this up. This is worthwhile to practice. 0.67 on top, 0.18 on the bottom, and when we work it out, we get 3.72. Okay, obviously this is greater than 1, isn't it? So if it's greater than 1, right, we say it is elastic. So the point of this video is basically to say that the elasticities change during, even along the curve, even a linear demand curve, it changes. All right, and we can kind of imagine this. I mean, what if we're talking ice cream cones here? Let's just imagine we're talking ice cream cones. Let's imagine we were charging $1 for ice cream cones. That's pretty cheap for an ice cream cone. And so when we calculate the price elasticity of demand, yeah, and then so hey, we increased the price by $1 because we found out it's inelastic. We want to maximize our total revenue, and we notice that we only lose a quantity of 2, so now we're down to 10, but our total revenue's gone up. So that's pretty good. So we want to keep on doing that while it's inelastic. And when it gets to unit elasticity, right, when it gets to a point where the elasticity is 1, then it's kind of counterproductive to keep on increasing the price. If we keep on increasing the price, then we actually lose total revenue. So here is a table of the previous graph we were just looking at. And as we can see, right, at the price of $1, quantity demanded is 12, total revenue is $12, right? And we're gonna, that's a 15% change in the quantity demanded. It's inelastic. So hey, if you've determined that it's inelastic, what are you gonna do? Well, you're gonna raise the price. It's inelastic, let's raise the price, $2, quantity of 10, but now we're making more money, right? And there we go. So anyways, and it's still inelastic, and you figured it out. It's inelastic. So what are you going to do? You want to maximize total revenue? You're going to increase the price. Increase the price to $3. And look, now you've even increased your total revenue more. And so that's great. And then you get up to the point where it's unit elastic, right? You increase the price, the quantity went down to 6, and your total revenue stayed the same. So now you're like, okay, so nothing happened, nothing changed. My total revenue didn't change. Now maybe that's a good clue. Maybe you shouldn't keep on increasing the price. But let's pretend you didn't study economics. You moved it up to $5. Ah, you increased the price too far, didn't you? Now total revenue just decreased. Now you're thinking, maybe I should lower prices down to $4. And you would be exactly right. And again, we're just talking about maximizing total revenue. We're not talking about your costs at all. That comes later on in the class. But if you're just looking at maximizing total revenue, you would want to do it, keep on doing it. If it's inelastic, keep on raising those prices until it is unit elastic, until you get a price elasticity of demand that equals 1.